Dear students, I am Khandakar Fazle Rabbi, lecturer, Milestone College. Today, we discuss about aromatic compound phenol. Now, we discuss about phenol. What is phenol? Phenol is an aromatic hydroxy compound. That means there are two parts in phenol. First one is aromatic part and the second one is hydroxy group. So this one is phenol. There are three types of phenol we get. That is, this one is monohydroxyphenol, that is monohydric phenol. This one is dihydric phenol, because here two hydroxyl group is present in this compound. The name of this compound is 2-hydroxyphenol, and another name is orthohydroxyphenol, because this hydroxyl group present in ortho position, and another name of this compound is catechol, and this one is trihydric phenol. This one is trihydric phenol, and the name of this compound is 2,3-dihydroxyphenol. That means 2 and 3 position carbon is attached with hydroxyl group. Another name of this compound is pyrogalol. So we can say that what is phenol? If aromatic ring is attached with hydroxyl group, then the compound is known as aromatic ring plus hydroxyl group. The name of that compound is phenol. General formula of phenol is AR. This one is aromatic part, OH. Now we discuss about the physical properties of phenol. Phenol is colorless crystalline substance. Melting point of phenol is 43 degrees centigrade and boiling point of phenol is 182 degree centigrade. Phenol is partially soluble in water. But we can say that phenol and water dissolves in each other completely in all properties above 66 degree centigrade. Okay, now the another name of phenol, this phenol is carbolic acid. So why we use carbolic acid? Carbolic acid is 5% water containing phenol. That means 5% water plus 95% phenol is known as carbolic acid. Carbolic acid. So what is carbolic acid? 5% water plus 95% phenol is the mixture of 5% water and 95% phenol is known as carbolic acid. Students, now we discuss about the preparation of phenol. The first one, preparation of phenol by Dow process. In this process, first chlorobenzene, if chlorobenzene is hydrolyzed in the presence of alkali at 150 to 200 atmosphere pressure and 300 to 400 degrees centigrade temperature, it reacts, this sodium hydroxide reacts with chlorobenzene and produce sodium phenate, and after produce sodium phenate, if it reacts with HCl or acid, then we get phenol. In this reaction, this NaO attached with a benzene ring, and hydrogen reacts with chloride ion, then produce sodium phenate. This one is sodium phenate, and this sodium phenate reacts with HCl. It produces phenol. This hydrogen reacts with oxygen. This one is known as Dow process. This process is known as Dow process. In laboratory, we prepare phenol by this process. This one is known as laboratory preparation of phenol. In this process, at first benzene reacts with nitric acid and sulfuric acid, then we get nitrobenzene. This one is nitrobenzene, and nitrobenzene reacts with tin plus HCl, then we get aniline. This one is aniline, and this aniline reacts with sodium nitride and HCl. The condition is 0 to 5 degrees centigrade temperature, and then we get benzene diazonium chloride. This one is benzene diazonium chloride, and this benzene diazonium chloride reacts with water, presence of heat, we get phenol. This process is laboratory preparation process. Dear students, now we discuss about why phenols are acidic but alcohols are neutral. If we see the structure of phenol, we see lone pair electron is present in oxygen. This lone pair electron shifts to benzene ring through resonance. As a result, oxygen hydrogen bond becomes weak, so it can easily donate proton and forms phenate ion. If we see, this lone pair electron shifts towards this carbon oxygen bond, and this pi bond shifts to this carbon. As a result, positive charge increased in oxygen. Now the resonance structure is here given. We see that positive charge increase in oxygen. That's why the bond between oxygen and hydrogen become weak. As a result, oxygen can easily donate hydrogen or proton, hydrogen ion or proton. That's why phenols are acidic. But in alcohol we see that this one is alkyl group. We see that alkyl group is present here, and this alkyl group is electron releasing group. The alkyl group is electron releasing group, so this alkyl group push electron towards oxygen atom, and that's why oxygen hydrogen bond becomes stronger. As a result, hydrogen and oxygen cannot donate hydrogen ion, and that's why we can say that alcohols are neutral. Dear students, now we discuss about the identification of phenol. Test 1. Taste of ferric chloride. If neutral ferric chloride is added to the aqueous solution of phenol, then complex compound diferric hexaphenate is produced, and the color of this solution is violet color. By this reaction, we identify this one is phenol. And test 2, taste of bromine water solution. If bromine water is added to the aqueous solution of phenol, bromine water is added to the aqueous solution of water, then the red color of bromine, disappears and a white or light yellow PPT means precipitation is formed. By these two reactions, we can identify phenol. Now, reactions of phenol. First, formation of benzene. When phenol is mixed with zinc dust, and is distillated, phenol is reduced to form benzene. Here, zinc reacts with oxygen and this hydrogen attached with this carbon of benzene ring, and here produce benzene. Now, formation of ether. If phenol is heated with sodium hydroxide, then sodium phenate is produced, and then the alkyl halide, if alkyl halide reacts with sodium phenate and form this compound name is anisole. This one is alkoxybenzene. This one is methoxybenzene. Here methyl group is present, that's why this one is methoxybenzene. This one is a ether. This one is an ether. Now, formation of aniline. When phenol is heated with ammonia, by the presence of dehydrating agent zinc chloride at 300 degrees centigrade temperature, then it produces aniline. And now, formation of picric acid. What is picric acid? This one is picric acid 2,4,6 trinitrophenol. 2,4,6 trinitrophenol is known as picric acid. This one is picric acid, and this picric acid is used for making explosive. It is valuable yellow dye for wool, and it is used to the identification of amine and aromatic hydrocarbon. So the reaction goes by the way, when phenol reacts directly with nitric acid and sulfuric acid, it produces picric acid. Now we discuss about preparation of paracetamol. If phenol reacts with nitric acid, then produce orthonitrophenol and paranitrophenol. By partial distillation, we separate this paranitrophenol and this paranitrophenol is reduced by steam plus HCl and it forms para-aminophenol. This para-aminophenol reacts with acetic anhydride and produce OH. This one is paracetamol. This one is paracetamol. If we see this reaction, OH, NH, H. This one is acetic anhydride, CH3COO, COCH3. This part attached with nitrogen and this hydrogen attached with CH3COO, and it produces paracetamol. Okay, thank you.